Hey you guys, I am going to be reading days 5 and 6 review book assignment, pages 85 through 86. Transfer of energy. Energy moves away from a region of high concentration or source to a region of low concentration or sink. Energy transfer from a region of higher temperature to a region of lower temperature is called heat energy. And of course, I'm going to be underlining important information and making some text annotations while I read aloud. Heat transfers thermal energy, the energy of the motions of atoms and molecules, achieving dynamic equilibrium. Heat will continue to move from the source to the sink until their energies are equal, establishing a dynamic equilibrium. At dynamic equilibrium, a region loses and gains equal amounts of energy. So I'm going to put that over here. Loses equals gains. If the dynamic equilibrium is between all forms of energy, then the temperature of the region or system will remain constant. Methods of energy transfer. Heat is transferred from an area of high concentration to an area of low concentration by one of the three main methods: conduction, convection, or radiation. Conduction. The transfer of heat energy from atom to atom or molecule to molecule when vibrating atoms or molecules collide is conduction. Conduction is most effective in solids, especially metals, because the atoms or molecules are closer together than in gases and liquids. However, some heat conduction can take place in liquids and gases. In Figure 5.3, conduction is the main method of the heat transfer from the source to the sink through the metal bar. Convection. The transfer of heat by movement in fluids, gases, and liquids caused by differences in density within the fluids is convection. So I'm going to make a little note back up here. Conduction is molecule to molecule or atom to atom, and convection is gases and liquids. Warmer portions of the fluid usually have lower density and tend to rise above the cooler portions. The reason for the rise of less dense fluids is that gravity pulls less on objects that are lower in density and pulls more on objects of higher density. Higher density portions of a fluid are pulled down and displace less dense objects, pushing them upward. The result is a convection current, a circulatory motion that transfers heat energy from one place to another. Convection currents transfer heat throughout Earth's atmosphere, hydrosphere, and most likely below the lithosphere. Radiation. The method by which heat is transferred via electromagnetic waves is radiation. So I'm going to underline that. No medium is needed to transfer the transverse waves that carry electromagnetic energy. This energy can radiate from its source across empty space. Radiation can also occur in liquids, solids, and gases, such as sunlight being transmitted through the atmosphere, gas, or through window glass, solid. X-ray electromagnetic radiation can pass through all but the densest materials. Radiation is also the method by which the sun's electromagnetic energy moves through space to other objects in the solar system. The higher an object's temperature, the more electromagnetic energy it gives off. In Figure 5.3, the higher the temperature of the metal bar, the more infrared energy it will radiate to the hand. For all questions 13 through 16, refer to the following diagram. A student is using the apparatus shown to perform an investigation. The two calorimeters contain equal amounts of water, and the metal bar is touching the water inside each calorimeter. At the beginning of the investigation, the temperature of the water was 100 degrees Celsius in calorimeter A and 20 degrees Celsius in calorimeter B. The room temperature is 20 degrees Celsius. 13. If there were a closed system, what would be the temperature when the system reaches equilibrium? 100 degrees Celsius, 75 degrees Celsius, 60 degrees Celsius, or 40 degrees Celsius. Number 14. Which conclusion should the student make after performing this investigation? 1. The energy gained by the cold water equaled the energy lost by the hot water. 2. The energy gained by the cold water was less than the energy lost by the hot water. 3. The change in temperature of the cold water thermometer equaled the change in the temperature of the hot water thermometer. Or 4. Energy was transferred between the two calorimeters primarily by radiation. 15. Which procedure would best increase the amount of heat energy that is actually gained by calorimeter B? Increasing the length of the metal bar, increasing the thickness of the metal bar, circulating air over the metal bar, or placing insulation around the metal bar.